begin in just a few minutes here, but before that, we'll do a quick recap. So we are at MIT right now in Cambridge, Massachusetts. So this is the Cambridge to Cambridge event. So this is the Cambridge in the United Kingdom, as well as the Cambridge here in Boston. And both have university students from the University of Cambridge and MIT competing in this event. So we have several events going on here. This one in particular is called Rapid Reversing. And I am your host, Tyler Nicewander from ForAllSecure. I also go by Tyler NI7 on the internets. So the way this event works, we have several machines, and they're installed with some basic tools. They have demo copy of IDA. They have some obj dump and so forth. And oh wait, I gotta change some names around here. Let me do that while I'm talking if I can. Okay, talking and typing at the same time is difficult. So let's give me a second here. So we'll be starting in just a few moments. We just ended our first round of the rapid fire event, and we'll be starting the new one very shortly. I'm just changing up the names before our next set of competitors comes here. All right, so the way this contest works is all the challengers are given binaries and 20 minutes. And in that 20 minutes, they have, in this case, 4 challenges. And all challenges, their goal is to jump to a function called execute me. So some of these challenges, the way to do that is a simple reverse engineering task. And some of the challenges, it's a little bit more complicated and maybe something like a buffer overflow. Well, they're all complicated, but so it varies between executing, I guess, defined behavior versus undefined behavior. So our challengers will be joining us in just a few moments, and we'll watch their screens as they try to understand these challenges and try to figure out what's going on. So again, there's a 20-minute timer here, and so they'll have 20 minutes to complete this challenge, and whoever gets the most challenges in that 20-minute time period will be the winner. Winners are chosen based on who solves the challenges first. So this is the semifinals rounds. This is the second of our 2 semifinals rounds, and afterwards, let's see at what time. Okay, I don't know what time. Sometime later, after this event ends, we will have the final round, which will be the top challengers. So we actually have been running this event since yesterday, alongside several other things, such as a live CTF, a Jeopardy-style CTF, lockpicking, and some other fun activities here in Cambridge, Massachusetts at MIT CSAIL. And just to remind everyone, I'm Tyler Nicewander from ForAllSecure. I'm not currently watching on Twitch. Maybe I should, in case people are leaving comments or yelling at me, because people are mean. Oh, yeah. Was anyone saying anything in chat?
Yeah.
What'd they say?
This is pretty cool. Please have more of these CTFs made. That's not long. Yeah.
Okay, cool. Oh, oops, I changed the window. I didn't mean to do that. All right. Oh, so our challengers are now entering the competition.
Almost all of them?
What?
Almost all of them?
Almost all of them. We've got 3 of the 4. We're waiting on one more. They might be pooping. It's hard to tell. Are they pooping? I don't know. I can't say poop. I can't. It's hard to talk to them. I don't have a Twitch account on here, I don't think. All right. All right. So all 4 of our competitors are coming in. We need to remind them all of the rules for the event. And aside from, oops, where's my? So we need to remind them all of the rules for the event, and at the same time, we need to give them all earplugs. So these competitors will actually be sitting right next to me here here at MIT CSAIL in Cambridge, Massachusetts. So we're all here in person. So these challengers will sit next to me, and we give them 2 levels of ear protection. We have some small foam earplugs, as well as kind of a more industrial strength over the ear muffs. So we do this such that I can walk you through the challenges as they're being solved. So we can watch what they're doing on their screen, and I can try to explain as much as I can about what they're doing. So again, they're just getting a quick recap of the event in the background here. In just a few moments, they'll come forward and start with their hands on the keyboards, and we'll start the event.
So he's going to explain what you're doing. Because of that, you shouldn't listen to what he's saying, so we give you some earplugs and earmuffs that you should wear. Because of that, we won't be able to talk. So when I saw some
Yeah, so just to remind people of the rules, so this competition has several challenges. Challenges vary between reverse engineering and binary exploitation. So the way this is going to work.
the other.
Oh, so all the way on the left, my left-hand side is Ronald Gill. After him is Witchicorn. Wow, you have a very interesting last name. How do you pronounce your last name?
Come on, Paul Richard.
He has a very interesting last name. After him is Julian, and finally, closest to me is Raul. All right. So they're just sitting down now. We'll give them a moment to get situated. So you can watch their faces right here. So we can watch their reactions as they deal with these very exciting challenges. So,
20 people watching.
wow, 20 people.
Yeah, you guys are live.
Say, shout out to the 20 people.
This is so exciting. 20 people. That's almost 23 people.
We've had 24.
Oh, wow. All right, so I'll wait for everyone to get their earplugs and everything in before we start. So once we start, they'll have 20 minutes. And during this 20 minutes, we'll kind of detail what they're doing.
You can press on top.
Yeah, I'll all right.
Alright, you guys ready? Yeah? Alright, you want to do the countdown?
Yeah, so, all right, everyone seems ready. So we're going to start the event in 3, 2, 1, go. All right, so we're off to a quick start. So there are 4 problems. We see Witchicorn immediately starting to run the problem and try to understand it. And we see Julian down in the 3rd spot immediately opening IDA. We see Ronald has actually already caused a seg fault, already sees basically what he has to do. So obviously a seg fault is a great first step towards understanding, great first step towards actually exploiting the problem. We see he's actually already jumped to the EIP 41414141, so he's actually already overwriting EIP, so he's off to an incredibly fast start. Let's see. It looks like Jillian has done the same thing. He's also the same thing. He's got this got an buffer overflow causing a interesting fault. He's got an illegal instruction fault. He must be probably just overwriting a couple of the least significant bytes of his address here, and not quite enough. That's my guess. But here we see Ronald is looking fairly close, so he's looking for the address of the execute me function. Remember, in all of these challenges, the goal of the competitors is to jump to the execute me function. So in this case, he basically has to overwrite the instruction pointer with execute me. So it's up at the top there, that 080484DD. So it looks like he's going to replace the bytes he thinks correspond to his EIP with those bytes right now. You can see a few people. Let me see, there's no solves yet. There's about 18 minutes remaining on the clock, but it looks like a couple people are very close to this first challenge right now. So again, Ronald looks the closest. Let's take a look at Rahul here. So again, he looks very similar in a very similar place. He's looking for this execute me address. He seems fairly close to getting it. Oh, and there we go, our first solve. So it looks like we have two actually. So Julian has actually solved it slightly earlier. I missed that about 13 seconds ago. And Ronald Gill solved it shortly thereafter. So it's going to be a very close competition right here. Should be exciting. So it looks like they're moving on to the next challenge, which is rapid reversing. So rapid reversing is a reverse engineering challenge. So there's no exploitation involved here. Instead, their goal is simply to reverse engineer what's going on, and the program will just jump to what their jump to their goal. It looks like we're over here. It looks like Rahul's getting close as well. He's got the address. It looks like he probably has some alignment issues going on here. This program, it's not necessarily the case that if you send the correct address several times, it'll line up exactly with how the instruction pointer is laid out in memory. And so he's probably going to take a little while to look at that. It might need to run a debugger or look at dmessage. So we see here, it looks like Julian is already working on this rapid reversing challenge. So we see here the point of this task is to basically reverse a circular shift. This gives some people a little bit of trouble. A lot of people don't understand that it's a 32-bit. They quickly are working, of course, because this is a very time-constrained competition. So they do this in Python, which makes sense. But it looks like he correctly ANDed that with a 32-bit number. So we'll see if he gets that real quick. So we've got also which corn has recently solved overflow. So again, it's a very close race. We've got 3 solves on that challenge, and it looks like the Rahul will be closing in very shortly as well. So again, for those of you just tuning in, this is the rapid reversing challenge here at the Cambridge to Cambridge event in Cambridge, Massachusetts. So we have students from the University of Cambridge in the United Kingdom have flown over here, as well competing with students from the Massachusetts Institute of Technology. And so they're competing here in several events. This is one of many. So this is the rapid reversing event. All of these competitions are put on by ForAllSecure, of which I'm a member. So we're hosting these events for these students to teach them about cybersecurity. So it looks like Julian here is trying to use hexadecimal to find the correct value to enter into this program. Looks like he's getting a little bit of trouble. Again, it sounds like a very simple program, but it's actually not so easy. So it looks like Ronald here is actually skipping around challenges. The order in which the competitors do the challenges is not important. Only the total number of challenges and whoever solves that number of challenges first. So all challenges are effectively valued equally here. So it looks like Ronald has decided that he's better off trying to do this second, this other binary exploitation challenge rather than solving a reverse engineering challenge, which he maybe doesn't feel so comfortable with. As we noticed, Ronald over here actually has source code for the overflow challenge. So after a few minutes, I think every 4 minutes, we release source code for these challenges. And so that way, if members are stuck, again, this is a very, very short time frame. So if people are stuck during this competition, we can adjust the difficulty by giving them a little bit more information. Adjust this camera here for a little. All right. So we'll see. It looks like we're still the case. We've got 3 solves on overflow and nothing left, with 13:37 left on the clock. Great number. Good timing. So it looks like we've got some people working on rapid reversing. They're using some internet resources. Again, this is all, they're allowed to use any resources they want, I guess except for Twitch. That would be weird if they started going on to Twitch. We should make sure that's, anyway. They can use any resources they want, including the internet. So all resources are available to them. So we see over here, it looks like, so we've got Rahul recently just solved this overflow problem. So we're now at all competitors have solved the first challenge and moved on from there. So it looked like over here we're on rather than going to the second challenge, the rapid reversing challenge, we've skipped directly to 1 in a million. So this challenge is relatively simple. It generates a random number based on the time and takes it mod 1 million. So there's naively, there's a 1 in a million chance of guessing it correct. However, the timer only changes once per second, which means that the number only varies once per second, which makes it quite easy to guess the number. It looks like he was looking at us, looking at his screen. It's a little bit meta there. All right. So it looks like we have Witchicorn here trying to understand this rotate instruction. So he's trying to make sure he understands exactly what's going on, which is a good idea. So again, this is a little bit weird because most languages, for example, C, don't actually have a circular rotate function. However, on the processor itself, in x86, there is a circular rotate. And so it takes actually a little bit of getting used to. For example, you might mess up and think that the 15H is actually going to be 15 decimal instead of 21. And so you have to make sure that you do the rotation correctly there. So it looks like here, so we have dropped the source for this problem. Again, another 4 minutes have passed. And so we can look and see exactly how this rotate is going on. But again, it doesn't look immediately obvious how to reverse this rotation. Oh, it looks like another challenge was just solved. Oh, it looks like Julian has just solved the rapid reversing challenge, so he did the rotation correctly. And so Julian is currently in first place. He was the first to solve the overflow, and now the first to solve rapid reversing. So we'll see if any of our competitors will be able to beat him. So like over here, we've got Witchicorn also working on this problem. He's got a calculator open. We saw Python as well, trying to see if he can do the circular rotation. So we now see Julian working on this 1 in a million task. Again, this is the task in which the random number is seeded, but only varies once a second, which means that you can actually, in fact, with a little bit of bash scripting, you could actually pipe the output from one of these programs into the other. And here we have Rahul over here also working on rapid reversing. He's got some ideas. He's got a little bit of the shifting done, but again, this is a circular shift, and he's only shifting in one direction. And again, I have to be, hopefully he didn't hear me. I saw him nod. He's the closest one to me. Didn't look like he heard what I said, but again, this is a circular shift, and looks like people are having a little bit of trouble with that, which is consistent with what we've seen so far. Ronald over here is still trying to understand exactly what's going on, keeping in mind that in a language like Python, for example, this behaves completely differently because Python has arbitrary precision numbers. Here, however, we've limited to 32-bit numbers, which means that it's going to act significantly differently. So some players have a bit of trouble with that. So it looks like Witchicorn here is taking a strategy we've seen a couple times so far today. So rather than doing the rotation, in something like Python, instead he's actually taking out the bits and rotating the bits manually by hand. This is a pretty reasonable strategy, and again, we've seen this before today. We'll see if that pays off for him. Oh, looks like we've got spaces in his expression. He's trying to put this into his calculator. All right, let's see if this number works out for him. Again, this very high-stress environment working with oh, looks like he got it correct, so now he just has to run it. Right, so it looks like Witchicorn is now in second place. So we've got 2 solves on rapid reversing, and all 4 competitors have solved the first overflow challenge. 8 minutes left on the clock, so we'll see if anyone else can move on from there. So it looks like Ronald is still working on trying to get this rapid reversing challenge done. He's got a decent idea. He's doing this in C, which is a reasonable way of doing this. That allows you to use 32-bit integers natively rather than having Python, which has arbitrary precision, which can actually kind of mess you up sometimes. So it looks like Witchicorn here is trying to understand exactly what this is doing. Again, we're seeding with time. However, this timer only changes once per second. So if he guesses it very quickly, he might realize that it doesn't actually change. But as you saw, it took him a little bit of time to enter that. And so several seconds have passed, so the number has changed. So it looks like here we have Julian, and it looks like he's actually moved on to the last challenge. He has not solved the 1 in a million task, but again, any order is sufficient. So it looks like he's trying to understand whether or not he can solve this challenge faster than, for example, he could solve the other. And any order is okay. However, this challenge is actually quite difficult. So in the other challenges where one simply needed to spam more or less the address correctly as long as they had the correct padding and offsets. This one's a bit more tricky. Instead of a simple buffer overflow, this also stores a pointer on the stack, and we make sure that we can actually write to that pointer before the function or before the program returns. So the trouble with this is that the trouble with this program is that if they simply spam the same address multiple times, they'll be writing an address which is not writable. It's a read execute address. Oh, but it looks like we just dropped the source code for 1 in a million, and so maybe he's going to switch back to that one, and hoping that the source code will make it a little bit more obvious what he has to do. So you see here, again, it looks like most competitors right now switching either between rapid reversing or 1 in a million. And it looks like several people are getting very close, but not quite seeing exactly what to do here. So again, the trick is that the SRAN time of null only changes once per second. And so all they have to realize is that if they run this very quickly in quick succession, it'll print out the answer and they can actually pipe this into another. In our last round of competitors, we actually saw some players actually completely rewrote the program in C just using SRAN time of null and piping it directly. And that worked for some of them with great success. We see here it's giving them a little bit of trouble to understand exactly what's going on and where the bug might be. So again, this is leading Julian to kind of skip over this problem and start working directly on the next one, this fire fault. The trouble here is he's currently not using any addresses which are writable. Again, the issue here is he's used to a standard buffer overflow problem, like the overflow problem he solved first. He solved the fastest in this competition. But this problem requires that you're actually able to write to the addresses that you're writing right here in memory. And so the issue is he's spamming lowercase a's as well as a address in the text section of the binary, and neither of these are addresses which one can legally write to. So as you see here, the program is actually trying to write, and it's causing a segmentation fault. He doesn't quite realize that the instruction pointer and the memory address, which is causing the seg fault, are different, which means that it's not seg faulting because it's jumping there, it's seg faulting because it's trying to write there. Additionally, the errors on the right-hand side here, you see errors 6 and 7, which actually mean that he's having not quite the issue which he thinks he is. So again, we're still in the same situation. We've got 4 solves on the overflow, but rapid reversing, we only have 2 solves on. So we've got Julian and Witchicorn, and Julian was the first to solve it, so he's currently in the lead with less than 4 minutes to go in this competition. So just reminding them right now, it's 4 minutes to go, so the source code for the last problem has just dropped. So we see Witchicorn here looking at this fire fault. So he's trying to understand what makes this difficult. And again, it's that done pointer equals 1 line. So what that's actually doing is saying that we're actually going to dereference that done pointer and write to it. And so a simple buffer overflow will completely clobber that memory location and will cause an error when someone tries to write to it. So we see again, many people working on this challenge, they don't quite understand what's going on. So So we see here he's got the seg fault at the exact address. So it turns out if he were to replace his return address here with something like a stack address, so a bunch of Fs or something in the BSS section of the binary, he'd be golden. But he hasn't quite figured that out. Oh, it looks like Rahul also solved 1 in a million. So he's actually the only player right now to have solved 1 in a million. However, he has not solved rapid reversing. And so, unfortunately, he's still, he's in a 3rd place. And one more challenge, for example, if he solves rapid reversing, that will put him in 1st. But currently, he is in 3rd place. So the standing right now is Julian, followed by Witchicorn, followed by Rahul, followed by Ronald. Ronald was the 2nd person to get overflow, got it very quickly in just about 2 minutes. However, he's having some trouble with these reversing challenges, which are a little bit of a different flavor. So just 2 minutes left on the clock here. We'll see if anyone's able to solve another challenge in time to change the standing. So it looks like Witchicorn here is trying to understand exactly what's causing the seg fault. So he's sending a non-repeating string to the binary. This is a great technique because sending a non-repeating string allows you to see exactly where the which locations are being written to in reference to the string that you're entering. Unfortunately, sometimes this is actually slower than doing things by hand. But we're coming up very close to the end of the competition here. We've only got about a minute left. So Rahul here is trying to see if he can solve this this challenge. It looks like he's incredibly close. He actually just might do it. So he's actually modifying the source code that we dropped. And his goal right here, I can't print F a number. We'll see if he figures this out. So his goal here is to reverse this circular shift that was going on. So he's actually modifying the source code that we dropped in order to use that for his rotation. He's got 50 seconds here. We'll see if he's able to do it. Oh, it looks like he will. So he's just got his number out. He's going to send that. 40 seconds left on the clock. We'll see if this is enough. Ooh, and he got that. So that actually puts him in 1st place right now. He's the only one to have solved 2 challenges. He just got those last 2 very quickly, 1 in a million in rapid reversing. So he's actually 1st place right now. So and there's only 20 seconds left on the clock, so it's unlikely to have changed. So it looks like Rahul is going to be our winner for the semifinals round of this rapid reversing challenge. So again, we just have 10 seconds left on the clock. Let's see what happens. Doesn't look like anything's going to change. Looks like people are a little bit giving up, and that's the game. Oh, I don't know why that screen did not go black, but all right. Game over. So let's give our contestants a round of applause. Woo! All right. Cool. So that concludes this round of the semifinals for our rapid reversing. So this final standing was so Rahul was in 1st, Julian was in 2nd, followed by Witchicorn, followed by Ronald. So Rahul was the only one to solve 3 challenges. He got 1 in a million and rapid reversing. Everyone got overflow, and Witchicorn and Julian both also had rapid reversing. It's a very close game. All did very well. So, thanks. So the